In our last video, we learned about a new, quicker, easier way, more compact way of doing division with polynomials called synthetic division. And really, there was not much downside to doing that method from what we saw. You just need to remember those couple of rules, and once you keep those in place, it's fast and it's really efficient way of dividing out polynomials. If you decide that you're going to do that method, though, the one issue I have with synthetic division, where maybe it's a little bit tougher, is when you're dividing by something where it's not just a simple x plus 2 or x minus 7 or something like that. When you have a coefficient in front of x, it does get a little tougher to use synthetic division. It can still be done. In a problem like this, though, I typically opt for long division, but it'll be up to you. You can either use this little trick to kind of fix the problem, or you can opt for long division when you see a number. Basically, this video is going to handle what happens when we have a number in front of our x. So if we're doing our synthetic division right here, the immediate problem, like the first one that jumps out at you, is that usually it's just like x minus 4, okay, the root's 4, and so on. But we have 2x minus 4. So it's not a big deal. You just have to do a quick algebra problem, set it equal to 0, and solve to find your root. And you end up getting that x equals 2. So our root to this problem is going to be a 2, and that's the number I want out here. We set up our inside just like we always do. And you're just going to power through and do your synthetic division. That first part was like kind of a minor hiccup where, oh, okay, I have to do a little algebra, but it's not so bad. The issue will come at the end. So go ahead and do your synthetic division, though. You carry down your negative 8. 2 times negative 8 is negative 16. I'm going to add and get 6. 2 times 6 is 12. I get negative 2. Negative 4. So I have no remainder. We got my constant term, my x term, and my x squared term. So my answer is negative 8x squared plus 6x minus 2. That's what I ended up with here. Now, the tricky part comes in. When you're doing synthetic division, it assumes you're taking just the, like, when you see this right here, we got a 2 right here, like, oh, my root's 2, so I must have had an x minus 2. That's how I would have gotten that root right there. It doesn't know that we actually had a 2x minus 4. We basically multiplied ours by 2. So it's kind of a problem right here, because if you divide the original problem by x minus 2, that's how you get this answer we have right here. It thinks we divided by x minus 2, not 2x minus 4. Now, there is a quick fix to this that kind of saves the day here. What we need to do, if you remember in my last video, I showed you that you can actually write the original problem, that original black problem with these two pieces. So that top line, if you factor it, you get those two pieces combined. And there's actually a GCF on the left side here. I'm going to go ahead and pull out a 2 from each of these parts. Because what we did here is we multiplied the root that we were supposed to have. If you multiply this guy by 2, and you distribute that in here, that's how we got our 2x minus 4. So I'm going to pull a 2 out of this guy, and I'm going to put it into this part so I can have my answer. And I'll show you how that works out. But basically, I'm going to pull a 2 out of this, and I end up with 2 negative 4x squared plus 3x minus 1. And I still have this x minus 2 sitting right here. What I'm going to do with this 2 I just pulled out is actually distribute it into the other parentheses. So now I get 2x minus 4, and I get the negative 4x squared plus 3x minus 1. That's supposed to be a negative 4 there in front. So when I divide 2x minus 4 into there, this is my actual answer. So if you wanted to do the division problem and you use synthetic division, you have to do a little bit of manipulation at the end there to get it to be what you want. If you did long division, you would have gotten this on the first try. No extra step required. This is just a little something you have to worry about. It doesn't pop up often, but when they ask you to divide by something like that. I actually have one more problem in this video, and if you're feeling up to it already, you go right on ahead and try it out. Answer's hidden under here. I'm going to go ahead and reveal it, so pause the video if you want to try it for yourself. But correct answer is going to be 3x minus 1. So let me show you where that came from. Again, we set up our synthetic division like normal, but here we got to do a quick algebra problem to find our roots. And when you solve that, you end up getting x equals negative 1.5. We have a decimal here. That's okay. You can still do synthetic division when you have a decimal root. We'll see how that works out here in a sec. So we got 12, 14, and negative 6 right here. When you do your problem like normal, we get 12. Negative 1.5 times 12 is going to be negative 18. So we got ourselves a negative 18 right here, negative 4. When we add, we get a positive 6, and there's no remainder. So I would have gotten 12x minus 4, but it thinks what I did right there was actually, my root was x, if it's minus 1.5 was x plus 1.5. This is what it thinks we divided by. So to get to what I actually divided by, I would need to multiply in, and I'll change colors here, a 4 to get back to that. If I multiply in 4 right there. So I'm going to pull a 4 out of that first piece here, and I'm going to stick it, sorry, the second piece, and I'm going to stick it in the first piece. So when I pull out my 4, I get 3x minus 1, and I'm going to take that 4 and put it on the left side. Distribute it in. I get my 4x plus 6, just like I started with, and then that's times 3x minus 1. So if you divide 4x minus 6 into the original problem, you get 3x minus 1. And that's how you can handle this little situation. Again, it doesn't pop up that often. If it bothers you doing this, just do long division on these sorts of problems. But overall, it's not too bad.